Hi, this is Michael Farragut, and I wanted to thank you for joining us once again between the borders. And today I wanted to do a little analysis on actually a piece of fiction uh, from the webcomic Schlock Mercenary. It's a fun read. It's fairly soft science fiction, a lot of hand waving, but it's fun, and he knows what makes a good story. I would really suggest checking him out, schlockmercenary.com. But uh, there is a there is something that came up, and if you're not caught up on the narrative, you should probably catch up before watching this. But Parnassus Dome switched over to Fusion for story reasons, and they have a photo of it or a drawing of it that just didn't make sense to me intuitively. So I wanted to take a look at it, and if I was going to be doing all this analysis, I figured why not share it? It's always a good thing to have something entertaining where you can demonstrate to people this is how you do something, so they can have it in the back of their mind the next time they need to do anything. But in reality, I nerd sniped myself. Um, I saw something, it didn't make sense, I wanted to figure it out, so I spent way too long running down how to figure out the answer, figuring out what answer I could, and then, doing all of this. And yeah, I definitely nerd sniped myself. And I even went out of my way to make sure that autogenic was exactly the word that I wanted, because there's nothing like nerd sniping yourself while nerd sniping yourself. This is what we're looking at right here. This is, I believe, one of the cities in Parnassus Dome. I think Parnassus Dome is the region more than anything. That being said, people are going to question the dome thing because I parse it internally as the Russian dome for home, not apparently dome means cathedral in German, or there's an acronym, at least that's what the Oval Wiki was talking about. Myself, it parses to home in my head. That's where I go with it. But what we have here is one of the systems. As you can see, the upper left we have a reactor, and the lower right we have the living arrangements, which you could call a dormitory. I have it notated as dome. Could be a residential district, whatever. Uh, but the center of rotation, which is a combined center of mass, is right there at the end of the reactor. And this didn't make much sense to me. Now, I obviously can't get things to precision here, but what we're doing is, once again, order of magnitude analysis. I can't tell you if it's off by 10 or 20%, but I know it's not off by 90%. This will let you know, one decimal place or another, the sort of direction this goes. And that's good for feasibility. And sometimes this is all you can get, especially in a realm of fiction. So, first thing I did is I wanted to figure out the length of the tether. The length from the center mass of the system to the center mass of the reactor, the center mass of the system to the center mass of the dome. And that was actually easy enough because the grid was laid out for me. I mean, it's almost as if Howard Taylor wanted me to do this work. I doubt that's the case. It simply looks good, but I mean, you use what tools you have available. I have two hands. Would I want to be so proud I'd use one? But we find that the center mass is roughly 1.5 units to the reactor core and 6.5 units to the dome core. And that leads us to a ratio of 4 1/3 to 1, or 13/3, which I'm probably going to keep around because, frankly, 13/3 just looks cleaner. And this gives us a ratio of between 4 and 5 to 1. That, like I said, it's an order of magnitude analysis. If we're going to be off by one in either direction due to my measurements or due to the center of mass, we know that that's going to be pretty close. And we'll move on from there. We'll see whether or not we get good information. Because if it turns out the reactor has to be, a kiloton per cubic centimeter, that's not going to work, right? But what we do first is determine the force from the rotation. And that's defined here as the force equals the mass times the radius times omega squared, omega being the radial velocity. Now, fortunately, the only force is from the tether. That means only the tether acts on both ends, and only both ends act on the tether. It's a two-force member. That means that we can place the F for both sides being equal, and thus simply place the mass of the dome times the length of the tether of the dome times the rotational velocity equals the mass of the reactor times the length of the tether of the reactor times the rotational velocity squared. All the rotational velocities on both sides, we're just going to get rid of that. We'll combine the terms, and we end up seeing that the mass of the reactor is 3 1/3 times the mass of the dome. Now, just keep this in the back of your mind. I want to point this out now. Submarines are about as dense as seawater. They have to be, because otherwise they'd pop straight out of the water or they'd crash to the bottom. That means they're roughly 1 gram per cubic centimeter or 1 metric ton per cubic meter. Spaceships are different, but that is a closed, self-contained system, self-reliant for the most part, that keeps people and a very powerful reactor, indefinitely is the wrong word, but months, years at a time, if necessary and properly equipped with food and the like. So that is a good starting point for what it takes to keep a crew alive while performing a mission. Now, the reactor is roughly cylindrical and is roughly 2 to 1 height to depth. Sorry, height to diameter. And it's roughly 2 units high, at least in the measurements that we have. The dome is conic, and is approximately 4 units high, again, about 2 to 1 height to diameter. This makes the volume of the reactor at this scale approximately pi over 2 units cubed. The volume of the dome is around 4/3 pi units cubed. And as you can see, I mean, if we wanted to find different sizes, the equations are set up exactly for that. But I mean, we're looking at this particular example, this particular rendering, which, as I think about it, could simply be an artistic rendering by PD anyway, so who knows. So, we're back to the original image, and now we have the volume of either side, U being units because we have no idea how large this grid is. So, here we have our math from earlier. 3 1/3 equals the mass of the reactor divided by the mass of the dome. Now, if we swap out the mass for the volume times the density, we see two interesting things. First, if you misread rho as P, the denominator has PD. So, yeah, apparently my accidental naming conventions have yet another PD pun in them. So, yeah, I don't know what to tell you. If you're a Schlock Mercenary fan, I can't imagine you're not if you're watching this. Yeah. So, we can end up using this to determine the ratios between the two densities, and we find out that the density of the dome times 28/3 equals the density of the reactor, or the reactor is around 9 times the density of the dome. Now, if the dome is 1 ton per cubic meter, that makes the reactor approximately 9 tons per cubic meter. This means if it was made entirely out of lead, 80% of the external volume would be made up by lead. Only 20% would be airspace or machinery inside. Of course, machinery inside would take up the weight of the walls, but considering that most equipment is not going to be as heavy as the lead, you can see that's not particularly suitable. Now, if we switch to uranium, I'm not sure why in the world you'd use uranium. It only has to be 50% solid. Hassium, the heaviest transuranic element that I could find, it would only need to be 22% solid. And in the universe of Schlock Mercenary, there is extensive use of fairly expensive, but at least available post-transuranic elements. And that means that just because this is the heaviest element that we currently know of in the transuranic elements, doesn't mean there won't be something heavier found in this fictional universe. And I can't account for that. But what we do find here is, yeah, I mean, this is feasible. I mean, I'm not going to go so far as to say reasonable, but it's definitely feasible. And there is there's some wishy-washiness here in the analysis because I don't know what sort of fusion he's using. Magnetic confinement, inertial confinement, wiffle ball, tokamak, that lithium-6 breeder system. I don't know, and we can't know. All the fusion that we have is under Unity, and obviously if he's using this as a power plant, it's greater than Unity, so yeah, I can't say anything. I assume that a lot of the volume is taken up with hydrogen in those tanks. I can't think of anything else that'd be in them, but it's feasible. And let's table the feasibility and such for just a second, because this will all wrap up pretty tightly here. I'm going to avoid doing gravity on this, because you can get effective gravity at any scale just by changing the speed, or at any speed just by changing the scale. You end up having issues with Coriolis effect and so on and so forth. But really, at this point, it doesn't matter. We can't determine the scale at all. If you take a look out that window, I mean, there are multiple cities. If Parnassus Dom is the entirety of the region and not just the one facility, which I believe it is, we've got 8 billion people spread out over who knows how many things. You might be able to take a look at the distance between those cities and figure just some general thing out, but I think it's a losing battle. These are what they are because Howard thinks they look good that way, and they do. He thinks it fits the story, and they do. And that's the thing with fiction, is it's close enough that you're happy to see it, that it works well, it feels good in the mind, but it doesn't necessarily make it accurate. And what surprised me the most is I looked at this, it instinctually did not look proper, it did not look like it would work, but I ran through the numbers and it's feasible. I mean, particularly once you think about the fiction aspect of it, it's actually very, very good. And I know Schlock Mercenary is not a hard science fiction story. Now, don't get me wrong, they are very, very good at trying to keep things as accurate as possible, given the circumstances of the story. And that's great. I love that. It's all about trying to tell the human tale of all of this, despite the fact that a good number of the mercenaries aren't human. But that's really where this all exceeds, and that's why I love this image. I mean, I can sympathize so much with bright light civilian places I'll never go, right? Still, the view's amazing. And I really wish I could share some of the better moments as well, but that's outside of the scope of this video, and they would all be incredible spoilers to people who haven't seen the storylines yet. So, nope, moving on. I just want to thank you once again, and seriously, if you have not read Schlock Mercenary, definitely give it a try. I mean, it has some very, very deep archives. It's been going for, oh goodness, is it 18 years now? It is a very comprehensive daily comic, but it's a lot of fun to read. And this has not been the first time that somebody from the community has sat down and said, all right, let's take a look at this. Let's figure this out. I think last time was actually when we ended up with a superheated warship. But again, I don't particularly remember. It's beyond the scope of this video. I'm Michael Farragut, and I want to thank you once again for joining us Between the Borders. I have of course, this YouTube account. You can always reach us as well at betweentheborders.com, Facebook presence, and we do have, at least for the month of January of this year, we had a podcast, which is certainly something we could start up again if the interest was there. And if there's anything else we can do for you, I mean, I I try to think of things that we can teach you that would be entertaining, but I already know what I know. So if anybody has any questions, please let me know, and I'd be very, very happy to try to put something together uh, to try to get people where they want to be, to try to make them the best version of themselves that they want to be. And of course, as always, please stay safe.